Well, hi everyone, and thanks for coming. I'm here with my friend and colleague Lorelei MUCCI. Lorelei could have easily been here last week talking about cohort studies. She does both research using cohort study designs and case control study designs, but I've asked her to come and give an example of a case control study, which she's going to do in a few minutes. But first, I thought it'd be useful if Lorelei, if you could tell us something about yourself, the type of research you do, and how did you decide to become an epidemiologist? What light went off in your life that said, this is what I want to do?
Great.
So, Lorelei, the floor is yours.
Thank you, Fran. And I'm really delighted to be here today and share as part of this exciting course. So I am a cancer epidemiologist, and in particular, I study prostate cancer. The studies that I'm involved in look at why men develop prostate cancer, and particularly why some men form a potentially lethal form of prostate cancer. And then also, after a man's diagnosed with cancer, are there lifestyle factors that they can engage in that will lower their risk of dying of their disease? And so these are the types of epidemiological studies I'm involved in. So actually, in terms of one of the critical points in my life that led me to be involved in this field was meeting Dimitrios Trikopoulos, who is a professor in our department, and he gave a course back in the 1990s on cancer epidemiology that really changed the world for me, and thinking about the importance of using epidemiology to understand biological questions, but then to apply it to public health and prevention. So that's how I got started. I was asked to give a critique of a nested case control study. And so I actually picked, you'll see the study that I picked was the study of pre-diagnostic selenium levels in toenails and the risk of advanced prostate cancer. So this is a topic that is a very important area of interest for prostate cancer researchers. Can we prevent advanced prostate cancer among men? And this study came from the 1990s. However, I think it really exemplifies nicely a nested case control study. Today I'm going to give you an introduction to nested case control studies. I'm going to be discussing the background of the hypothesis for this particular study, as well as the overview of the design. And then finally, we're going to walk through together 4 questions that I've picked for further discussion by you and to think about critiquing this specific paper. So I thought I would start by giving you a reminder about sort of what a nested case control study is. So as Fran presented in his overview of case control studies, you should think about a case control study very similar to how you think about a cohort study. It's just an efficient and valid approach, an alternative to cohort studies. If you remember from Fran's lecture, the reason that a case control study is able to observe a population more efficiently comes from using the controls. And so the purpose of the controls is to provide information about the exposures that you would have gotten if you had completely looked at this question within cohort studies. And actually, although I'm presenting on the nested case control studies, the case control studies are actually a family of different study designs, and they all are related, but each unique part comes from the way the controls are sampled from your population. So let's look at an example of this. So here I have an example of a hypothetical cohort study. You have individuals who are all at risk of the disease of interest at the start of the study. And at the start of the study, because they're at risk, nobody has developed your disease of interest. So for example, if we were studying prostate cancer, these would all be men and they'd all be free of prostate cancer. And then with a cohort study, you follow individuals forward in time and you observe what happens to them. Well, during time, some of the individuals will develop your disease of interest, so in this case, prostate cancer. Some people may die of another cause before the end of the study, but you follow them for a certain amount of time. And then occasionally, and hopefully not too many people, you might lose them to follow up. And then finally, you have some men who reach it to the end of the study. So this is the hypothetical cohort study. So with a nested case control study, if you remember, what you do is instead of, with a cohort study, you would have a case of disease, and then you'd have as your in your analysis, you'd be looking at all of the other individuals who are still at risk at that time. With a case control study, we're going to sample specific individuals from each of these windows of time. And those controls are going to give us information about the exposures if we had really followed the whole cohort study and knew what happened to the cohort. So we're sampling from this window. So for example, for this case, we can sample any of these individuals randomly. And that gives us information about the prevalence of an exposure that you would have had if you had followed the whole cohort study. So that's a nested case control study. So in this study, the researchers were interested in the question of whether selenium levels could be associated with a lower risk of advanced prostate cancer. And so I thought I would give you just a little bit of introduction about prostate cancer, which is actually a really interesting but very challenging cancer to study and to understand risk factors. We actually know relatively little about why men get prostate cancer. And the reason for this is the fact that many men have a prostate cancer. And so this figure here actually is a study of men who died of other causes. So it was an autopsy study. And then the pathologist looked at the prostates of these men. So these men had died of other causes. The pathologist looked under the microscope and saw the following, that among 50 to 59-year-old men, these are all men who have died of other causes than prostate cancer, actually 50% of them had what the pathologist would have called prostate cancer. And for men aged 70 to 79, almost 80% of those men had prostate cancer. And so really one of the challenges in studying the epidemiology of prostate cancer is the fact that the incidence is so tied in with how much diagnosis and how much screening is going in the population. And really, when we think about epidemiology and prevention of prostate cancer, we really want to focus on risk factors that are associated with advanced or lethal forms of prostate cancer. So this is what this study did. So why might we be interested in the hypothesis that selenium would be associated with a lower risk of prostate cancer, and particularly advanced prostate cancer? Well, his friend had previously presented a study looking at selenium and risk of cancer overall. Individuals who had higher levels of selenium had a lower risk of cancer. And the idea is that selenium acts in antioxidant pathways and therefore would lower risk of disease. So for prostate cancer, some of the strongest evidence actually came from a randomized study presented here in this figure. So it was actually a randomized controlled trial of almost 1,000 men who had non-melanoma skin cancer. And actually, the primary purpose of the study was to see whether if you gave men who had previously had skin cancer, would it lower the risk of getting a second skin cancer? So that was the primary purpose of the study. So there were 1,000 men who were randomized either to placebo or high selenium yeast. They were followed on average for 7 years. And then what they saw actually, that there was no effect of selenium on getting or preventing a second cancer from happening. However, they did note an overall reduction in risk of cancer, and in particular, they found that the men who were randomized to selenium had a much lower risk of prostate cancer, so the relative risk was 0.4, or the men randomized to selenium had a 60% lower risk of developing prostate cancer during follow-up compared to the men who were on placebo. So this was very strong evidence for the hypothesis. But it was the primary endpoint in the study hadn't been prostate cancer, it was actually skin cancer. So what followed was a number of epidemiological studies to examine whether men who had high levels of selenium in their blood, or looking at a biomarker of selenium, whether that could be associated with a lower risk of prostate cancer. So the research community wanted to follow this up. And so with selenium, as many times studies of diet and nutrition will ask participants to fill in food frequency questionnaire and ask about different dietary factors. However, with selenium, you actually need to measure a biomarker or levels of a biological marker in order to know how much selenium people are exposed to. And the reason is that the amount of selenium that a person takes in really depends on where food is grown. And so, for example, there was a really interesting natural experiment in Finland. So back in the 1980s and before, Finland actually had very low natural levels of selenium in the soil. And as a result, the food that was grown in Finland had very low levels of selenium. And overall, as a population, selenium levels were quite low. And there had been really interesting evidence that selenium was associated with a lower risk of cardiovascular disease. So Finland undertook a nationwide program, and they fertilized all of the soil, agricultural soil in Finland. So the idea was that if you grew food in this higher selenium content soil, you could increase selenium levels in the population. And in fact, if you could see this study, this is looking at the selenium content in cheese and then in whole milk. And the fertilization occurred at this point in time. So if you look at the amount of selenium that were in these food groups before compared to after supplementation, you can see this big increase in levels of selenium in these specific foods. And that was solely due to the fertilization of the soil. And similarly, if you actually instead looked at the blood levels of different people in Finland, these are two different cities in Finland. If you look at the blood levels, you can see that the levels of these Finnish residents are much higher in the time point after the fertilization compared to before. So this is to say that we really need to do a biological marker of selenium in order to study the association between selenium and advanced prostate cancer.